when we factorize two terms in exponential, there are two kinds of questions that we can get. The first one is called taking out a common factor. The other one is called difference of two squares. So I will do number D and number A, and then you can come and check if you understand the lesson by doing number B, and then you will also do number C. Now let's get to that. Now, if we look at number A, on number A, we are already told that we have 2 to the power of 2x, and then we also have 2 to the power of x. Now, guys, we've already done a question like that. I hope that you've seen a video whereby we're doing a question similar to that. The difference between this question and that one is that here we're dealing with two terms on the numerator, but we had one term on the denominator. So it will be very helpful if you have watched this video. Now, how then do we approach this question anyway? What we have to say is that, okay, since there's a minus, as we can see, there's a minus or a plus, it means that you have two terms on the denominator, you have two terms on the numerator. What I will then propose is that since we have a plus and a minus dealing with two terms, we'll have to rewrite this thing as 2 to the power of x all squared. Now, this and this, they're exactly identical. Minus 2 to the power of x all over 2 to the power of x minus, then we'll have minus 1. Now, guys, this becomes clear that we have 2 to the power of x here. We also have 2 to the power of x. But let's make it a little bit simple so that everyone can see. We will then say, from here, let 2 to the power of x to be equaling to k. Now, meaning, because here there's 2 to the power of x, we'll come and put a k like this. Here there's 2 to the power of x, we'll come and put a k. And then here we'll come and put also a k. So if we write it correct, the 2 to the power of x, we remove it and then we replace it with, so here we will have k all squared minus k all over. Then we have k minus 1. Now from here, guys, we can clearly see that if we move on with this, we'll come and say, okay, but here we have k squared minus k all over k minus 1. Now, on the numerator, these two are not like terms, but we can clearly see that there's a k here and then there's also a k here. So we'll then say, let's take out k as a common factor. If you take k as a common factor, what you are then remaining with is that here it's squared. So if I put another k here, it should say k multiplied by k, it will give me k squared minus. Now what should I put here such that when I multiply, it will give me k? So I would put 1. So k multiplied by 1, it will give me k. This is going to be all over k minus 1. Now, as you can see here on the denominator, we have k minus 1. So I will say this one and this one, they divide each other out. Now, if those two divide each other out, then you'll be left with k. But remember, we know what is k. We said our k should be equaling to 2 to the power of x. Then this was going to be our final answer. So here we're factorizing by taking out a common factor. Now let's check this question if we can also take out a common factor. If we look at number D, now the first thing that you have to see with number D is that you have 2 to the power of x, which is a prime base. And then here you have 4 to the power of x, you have 16. Now, because this one is an index 1, I'm not going to change, but the 4 will change. Now, because this one is to the power of 1, we won't change. So we change something that has an index with a variable. Makes sense for us to change that one. So we'll have 16 minus, open bracket, 2 to the power of 2 multiplied by x. Now, what did we say? We said this can be rewrite as 16 minus, open bracket, 2 to the power of x all squared all over 2 to the power of x minus a 4. Now we can clearly see here that if we put a square root here, it will give us a 4. And then if we put a square root here, it should give us 2 to the power of x. But just to make it a little bit simple, I made a mistake here. I didn't write the denominator. Just to make it a little bit simple for ourselves, we can then say, okay, let's rather do it this way. Let's say, let 2 to the x to be equaling to k. Now, if we say let 2 to the power of x to be equaling to k, it means that now we will have 16 minus k squared all over k minus 4. Now, as we can see on the numerator, we have a perfect square and then we also have a perfect square. But the problem with our perfect square is that on the denominator, as you can see, your k is positive, but here your k is negative. Now, we need to make this such that it looks like the denominator. How do we do that? Now, in grade 10, we did something like this. We'll factorize or we'll multiply with the negative. If we put a negative here, what is going to happen is that we put a negative here. Whatever was positive is going to become negative, and then this is negative is going to become positive. Now, meaning this thing can be written as k squared, open bracket, minus, k squared is positive, minus 16, close bracket. Now, this should be written all over k minus 4. Now let's go on and factorize this. Then we have minus, open bracket. And then we'll say that we have k here, and then we also have k here. We'll have minus, we'll have a plus. Since it's the difference of two squares, we'll have 4. We'll have 4. And then this is going to be all over k minus 4. Now, as you can see, guys, you have k minus 4, you have k minus 4. K minus 4 can divide the k minus 4. Now, after these two things have divided each other, you're going to be left with minus, open bracket, k plus 4. Now, we know what is k, then we'll have minus, open bracket, 2 to the power of x plus 4. Then we can leave our answer right here. That will be it for our lesson here, guys. Now, as we said, you can come and check number B and number C.